Now let's do some programming. Let's implement stack in C++. So stack is actually LIFO, which means last in first out. So we will implement stack in C++ using arrays. We can also use linked list. Linked list is more flexible, but right now we are using arrays, and in next couple of lectures we will be using linked list to implement the stack. So while using array, we will use index variable to have LIFO impact. I mean to say, we will increment index when we are pushing, and when we will popping, we will decrementing the index, so the last pushed item will be popped. So let's start programming. I write a class, and we can name it anything. I name it my tag, and let's have some data member of this class, integer array. It is a array of type integer, and then we have another class of let's have the pointer of int type. We will define initialize and define the array on heap using a new keyword, so that we can define the size of array by asking from the user. And here's another variable index, which will be incremented or decremented with push and pop operations. And here's another data member, that is size of the stack. So let's define the constructor, which would be public my stack. And in constructors, we do something that we need to do in start. We will allocate the array pointer using new operator, new it, and the size will be defined by the user. So let's have an argument of s, and it is a size, and size is equal to s, and the array is according to that size. And in start, we initialize index with -1. -1 means the array is empty, the stack is empty, and the index is pointing to nothing. When index is 0, it's actually pointing to the first element. So this is it. Next we define some utility functions like is empty or is full. So these are very simple. Bool is empty, it will return true if the stack is empty, and stack will be empty when index is -1. Will return true, otherwise we will return false. And similarly, we write bool is full and stack will be full when index will be 1 less than the size of the stack. I mean to say, if index is equal to size -1, as the index of array is always 1 less than the size. Like if this is an array, so when the array is full, the index will be 3, and the size of the array is 4. So 4 minus 1 is equal to 3. So we define it here. When index is equal to size -1, we will give them as return true, else we will return false. And so now we have defined some utility functions. Now we define the actual push function, which will push the number into the stack. And so parameter will be int number. And here we will see, first of all we will check whether the stack is full or not, and if is full, we will not be able to push anything. We will simply show the message that stack is full, right? Otherwise we will push the value on the stack, and while pushing the value we have to increment the index operator. For example, for the first time the index has value of -1, so we will increment it and it will become 0. So we will push the first item on the 0 index, and so we will push the item, the value on that index. So this is the simple code of push, and the pop is just inverse of this. Void pop, we will simply move back the index by decrementing it, and first of all we will check if is empty. If the stack is empty, we will simply show the message that stack is empty, nothing to pop out. Okay, otherwise else what we will do, we will simply decrement the index. That's it. You can also delete the content of the array, or you can but it doesn't matter because anyhow it will always contain some garbage, so we will simply decrement the index. So this is the pop operation. So if you want to get the current value that is at the top, you can define another function that will be int top. It will return the current value that is sitting on the top, and first of all we will use this same condition that if the stack is empty, we will say stack is empty to pop. Otherwise we will, and in this case we have to return something. So what we will return, we will return simply -1, and -1 means the stack is empty. Else we will return array index. So we will return the value at the current index. So let's test this class. Here we define create an object of my stack. I name it stack, and it is asking for an argument because the constructor demands an argument, that is the size. So let's say the size of this stack is 5. It will define an array of size 5, and so we can push 5 values into the stack. So stack dot push 6, and then we push another value, and other value. So now we have pushed 4 values and another value. So now the stack is full. Now if we push another value, it should give out the message that stack is full. Let's try and let's check. So now it's giving the message stack is full. So this 11 was not pushed on the stack because the size of the stack is 5 and we have already pushed 5 values. Now if we check the top value, that must be 0 because 11 was not pushed. So let's see why this error is giving. To the top, so let's check. So yes, it is returning 0 because 0 is at the top So now let's pop some values from the stack dot pop. So this will pop 0 value, next it will pop 2, next we will have popped 4. So now let's check what is on the top. Now the top should give us 6. So let's see. Okay, it is giving 6. So this is the code of stack, and you can play around with it. And in the next class we will check how to make this code generic, so that we can use the template, and we can use, instead of fixed int type, we can use any type of value. So stay tuned.